Hi friends, welcome to GMK Tutorials. In this video, we are going to see about the image shortening using frequency domain filters. In the previous videos, we discussed regarding the image smoothing, that is nothing but image can be smoothened by attenuating the high frequency components, therefore which gives a very smoothing images. So in this section, we are going to attenuate the low frequency components without disturbing the high frequency component. So the high frequency component means that it consisting of some edges information, edges like this. So this kind of information is protected with the help of these techniques. So for that purpose, in case of the high pass filter, which attenuates the low frequency components, In case of the high pass filter, we have three types of filters are there. That is nothing but first one is nothing but ideal HPF, ideal high pass filter. Second one is nothing but Butterworth HPF. So third one is nothing but Gaussian HPF. These are the three types of high pass filters are available in case of the frequency domain to sharpening the images. So let's see one by one with respect to their frequency domain equation, characteristics, and like this. Let us move on to the first one. So that is nothing but ideal high pass filter. Ideal high pass filter. So the ideal high pass filter means that it is a quite opposite to the low pass filter. Generally, if you are observe this one, this is the low pass filter characteristics. The quite opposite means that in case of the high pass filter, which attenuates like this. So that means it starts from somewhere else, that is nothing but D naught. So this is nothing but characteristics of H of omega of the high pass filter. This is nothing but D of U comma V. The amplitude of this one is nothing but 1. So from this diagram, from this graphical representation, I can represent the mathematical equation that is nothing but H of omega value is 1 from greater than D naught. That means D of U comma V greater than D naught. At the same time, this region, this value is equal to 0. Therefore, 0 for otherwise. So this is a representation. For high pass filter, where you know that I think all of you having some idea that is nothing but D of U comma V is nothing but distance from the center. This is a center from the center to U comma V variables. That is also very important parameter. In case of the ideal high pass filter, what happens is that which attenuates the low frequency component. That means its ideal low pass filter, ideal HPF. That means ideal HPF means that it attenuates the low frequency. Therefore, image sharpening can be achieved in the frequency domain. The characteristics are observed in the previous section. That is also very clear. Moreover, where D naught is nothing but some positive constant, or else we can also call it a cutoff frequency. So it is also called as a cutoff frequency. So this is a very brief introduction about the ideal high pass filter. The basic use of ideal high pass filter means that which is used to protect the edges and the sharp transitions in the image, because of it gives a lot of information regarding the shape of the objects and all those things. So that's why it is we need to protect the corresponding sharp edges and transition in the image also, while it is used for many applications. So for that purpose, image sharpening is also very important, that can be achieved with the help of a high pass filter. So thank you for watching GMK tutorial, guys. So please subscribe our videos still if you are not subscribing our GMK tutorials. So thank you, guys. Thank you.